Any questions? The last thing we did. This was, all right. We talked about position. Where an object is with respect to 0 or the origin or something that you're considering to be the middle. Displacement, where an object is with respect to the starting point. Or change in position. And the symbols for position, X is what I tend to use, but S, R, Y, Z, and displacement, since it's change in position, capital delta represents the change, and so we got delta X, delta S, delta whatever letter you're using for position. So if I have some sort of coordinate system here, and I start at this point, so this would be the origin right here. I'll just write 0. So it's 0, 0 in math, but if you consider that the origin, my initial position would be a vector like that. That's my initial position. I then move to here. That is my final position. And so my displacement is the change. It's from where I started to where I ended. So that would be my displacement. And it probably helps if I have this. So if I want to make my birthplace my origin, that's supposed to be the United States. I was born somewhere around here. I then am now here. So my current position would be represented by that vector. If I had a map, it would just be a line from where I was born in Florida to where I am right now. It is direct. So let's say that is 400 miles north and 20 miles east, obviously just making up numbers here. Then I can express my current position in terms of that. Now this is, so I would say 400 miles north plus 20 miles west. Obviously, as we've talked about before, that's just way too much to write, so we come up with a shorthand notation of I hat, J hat, or I hat. You could set up different systems, but up, down, left, right works a great bit of the time. And then I could just write my current position as 400 miles, J hat, plus minus 20 miles, I hat. And the negative just means opposite. So I hat's that way, negative I hat would be the opposite way. So this is just shorthand notation for where I am right now. Someday, I have to go right here, wherever that is. Tupelo, Mississippi. If I consider this to be my starting point, and I travel to here, then we can. That would be my displacement. It's where I am relative to where I started. It's not my position, because my position still has to be based upon what I consider to be the origin. So that's my initial position, that is my final position, and displacement is where I am relative to where I started, position is where I am relative to what I consider to be the origin. Now, we went through an exercise with just displacement and position, just a one-dimensional problem, and let's just sort of refresh our memories on that before we hit velocity. So I'm going to consider that to be the origin. I'm going to say to the right is positive, and I'm going to make that my starting point. All right. My position, positive, negative, or zero. A couple people were brave enough to give the right answer. Anyone else? Brave? All right, we got one more. My displacement. Positive, negative, or zero.
Positive.
I heard two different answers there.
Positive. Zero.
Why positive?
Because you're to the right of the origin.
Your displacement that you are right now
Yes.
is positive towards the positive, on the positive side.
On the positive side of?
Of the origin.
Yes, but displacement is where I am relative to my starting point, which is right there. So whoever said zero? Yes, spot on. My displacement now?
Positive.
My position? People are being very shy here. Let's try that one again. Well, in unison. Will bring tears to my eyes. Probably internally, but. My position?
Positive.
Okay, that's slightly better. All right, what about right now? My position? My displacement? It is indeed negative because I'm on the negative side of the line that disappeared, my starting point. And my position now?
Negative.
And my displacement?
Negative.
All right. So now, the next one, velocity. So we have the time rate of change of position, which is just a fancy word, fancy way of just writing that the velocity is the change in position over the change in time. And, or it could also be how fast an object is moving. And in what direction? Now, in terms of vocabulary, if I just say what is the displacement, as demonstrated just then, that was about overall displacement. If I'm talking about velocity, and I just say velocity, that is instantaneous. As opposed to average. And I think in the lab, we went over with a number of groups what average velocity is versus instantaneous. But in terms of instantaneous velocity, it's just which way am I going? Give people a chance to catch up before we do the next round of plus minus zero. Still assuming the same starting point, same origin, same positive direction. My position, positive, negative, or zero.
Negative.
My displacement.
Negative.
My velocity.
Negative.
Am I going in the negative direction? I assume I'm not swaying.
Zero.
Yeah, my velocity is zero. I'm not going anywhere. All right, so now, my velocity?
Positive.
Indeed. Look back up. You can get a look at.
Negative.
All right. Yes.
Okay.
My velocity,
Positive.
my position,
Negative.
my displacement,
Negative.
My velocity,
Positive.
Positive.
still. My velocity now,
Negative.
so velocity just cares about which way you're going. Let's talk about velocity, also average versus instantaneous. Come back to it. That's supposed to be a track, overhead view of a track. I'm gonna start here. And I'm gonna race Usain Bolt, or whoever is the fastest man alive now. Is it still Usain Bolt?
I think so.
I gotta know.
No, I think it's, I forgot his name though. but
Okay.
it's not.
I'll stick with Usain Bolt for the moment. All right, we're gonna race around the track. This is our starting, we're just gonna go around once. So Usain Bolt goes around, zips around. He's got the inside, that's why it might appear that he beats me. So let's say he does it in 40 seconds. I go around and I get back there in 200 seconds. So we traveled 400 meters. My average speed, well, speed, I'm just gonna take that except drop the vector symbols, is distance over time. My average speed would be the distance I traveled, which was 400 meters, divided by the amount of time it took me. So 2 meters per second. It would not be instantaneous. I would start out, I think, pretty fast, and then I would probably just collapse halfway around the track. And then crawl. So that's pretty darn fast for crawling. So this is. All right, Usain Bolt, he goes 400 meters in 40 seconds. What is his average speed? Yeah, give me the full thing.
Meters per second.
Yeah. All right, so just looking at speed, it looks like he's faster than I am. 5 times faster. However, I prefer not to look at it that way. I'd rather look at average velocity. So average velocity is just displacement over time, or change in position over time. So at the end of this race, what is his average velocity? It looked like, Anna, you were mouthing something, but I couldn't quite catch it. No? Okay. All right, going back to this, our formula for average velocity. We have displacement, so when he finishes the race, what is his displacement?
400.
That is the distance traveled, that is not his displacement.
Is it 0?
Pardon?
0?
Right.
Because he ends where he ends where he began.
After 40 seconds, he hasn't gone anywhere. So his displacement after 40 seconds is 0. So when he finishes the race, his average velocity, which is displacement over time, is 0 meters over 40 seconds. And then officially, it's a 0 factor. So that's Usain Bolt. And then when I finish the race, what is my average velocity?
0.
I am as fast as Usain Bolt. Just have to look at it right. Because when I finish the race, I haven't gone anywhere. It took me 200 seconds to do that. But I can take it one step further. When he finishes the race, I'm probably about here. Who has a greater magnitude of average velocity when he finishes the race? Now the words here, magnitude means that in the end, I don't care about the direction. We know that when he finishes the race, he has an average velocity of 0 meters per second. Will my average velocity be 0 meters per second? That is right. Oh, you're saying yes?
No.
Okay. Anna says no. Anyone want to fight Anna over that? Or do you just trust her? Looks like overwhelming trust. The answer is no, because I've gone somewhere. After 40 seconds, I am here. After 40 seconds, he's gone exactly where he started, so he hasn't gone anywhere. So my average velocity would be that displacement divided by the 40 seconds, and that magnitude's not 0. I am faster than Usain Bolt. Just have to look at it right.
The question that you just asked was who has a greater magnitude of
Average velocity.
average?
And that would
That would be you.
do it.
Yeah.
Yes. All right, questions here?
And it's because in 40 seconds, you're at a certain amount of meters and Usain Bolt's at 0.
Yes.
Okay.
He's back at the starting point. So therefore, as he's back at the starting point, his displacement is 0. All right, next step. Acceleration. Time, rate of change of velocity. In other words, acceleration, average acceleration, this must be a vector symbol, is the change in velocity over the change in time. So as was discussed last Thursday, right, Thursday, there's acceleration if the velocity changes. Or non-zero acceleration if the velocity changes. So, if you were driving a car, what are the 3 things, assume automatic transmission, what are the 3 things that you have easy access to that would be considered accelerators? In other words, 3 things that would change your velocity. There's one. Automatic.
Timers? No.
So, brakes, another one. And what's the third thing?
Your wheel?
Which wheel?
That's the steering wheel.
Steering wheel. Steering wheel. Holding up the wrong number of fingers there. Steering wheel. Because the brake will slow you down, so definitely a change in how fast you're going. The gas pedal will speed you up, definitely a change in gas and how fast you're going. And the steering wheel will change the direction you're going in. If any one of those, if you speed up, slow down, or change direction, there is acceleration. And what we'll find out in chapter 4 is if there is acceleration, there must be a net force acting on you. The only reason anything would change in your velocity, there has to be something causing it. All right, so again, starting point right here. My position doing positive, negative, zero again.
Positive.
All right, my displacement,
Positive.
yeah, because I'm on the plus side of my starting point. My velocity,
0.
my acceleration.
0.
Now I start moving this way. At the moment that I started moving, what was my acceleration?
Negative.
Was there, I heard negative was the loudest thing I heard. Why positive?
You're accelerating.
Yes.
You're speeding up, not slowing down.
All right, so so I started moving, so my velocity became negative or positive?
Negative.
All right, so I started at 0. So my initial velocity was 0. My final velocity was something negative, we'll just say negative 2 meters per second. So if I go from 0 to negative 2, is that a positive change or a negative change? The change in velocity is negative 2. It's the final minus the initial, negative 2 minus 0. And if my change in velocity is negative, my acceleration is negative. The idea that acceleration means you're speeding up and deceleration means you're slowing down, well, deceleration does mean you're slowing down, but deceleration is not a physics term. Acceleration is a much broader definition. You're speeding up, slowing down, or changing direction. So in that case, I was speeding up in the negative direction. I have negative acceleration. Now I'm traveling, my velocity now,
Negative.
try that one again. Sorry, stunned you with that last one. Here we go. My velocity,
Negative.
and then I come to a stop.
0.
My acceleration, as I'm coming to a stop.
0.
If my acceleration is 0, my velocity did not change, but I slowed down. It's one of those two.
Positive.
So you're insisting negative, if anyone would do the argument